Something extraordinary has just happened. In the final hours of November 11th, 2025, a fresh set of images of 3I Atlas arrived, images so unexpected, so utterly out of line with every prediction we had, that they instantly rewrote the conversation around this object. For months, astronomers around the world had prepared for the likelihood that Atlas would fragment after its close pass by the Sunday most natural interstellar comets do. Many don't even survive the heat, but these new observations show something no one was ready for. Atlas is still intact, not cracked, not shedding fragments, not breaking apart under the stress of perihelion. Just one single coherent body drifting away from the sun as if nothing unusual had happened. And the source of these images only adds to their weight. They were captured by legendary comet researchers David Jewitt and Jane Liu, the very people who helped redefine our understanding of small bodies in the solar system. Using the Nordic Optical Telescope in La Palma, with its powerful 2.56-meter mirror, they recorded the most detailed post-perihelion views of 3I Atlas to date. What their data reveals is subtle, but its implications are enormous. Because if Atlas truly survived perihelion intact, then all the assumptions built around its natural comet identity suddenly look much weaker. Something about this object is refusing to behave the way a comet should. And this, right here, is where the story begins to break away from conventional explanations. The question now is simple. What exactly are we looking at? If the new images were already astonishing, what happened next elevated the entire situation into a different category. Within hours of the data becoming public, Avi Loeb, arguably the most provocative and relentlessly analytical figure in modern astrophysics, published a new breakdown on his blog. And his conclusions were not just surprising, they were devastating. Loeb didn't simply confirm that 3I Atlas remained a single body after perihelion. He went much further, showing that this one detail alone completely undermines the traditional comet interpretation. His tone was clinical, his numbers precise, yet the implications hit like a hammer. Atlas is violating the rules that natural comets are supposed to obey. He began by walking through the observational facts, nothing speculative, nothing sensational. The object survived the intense solar heating. It did not disintegrate. It did not fragment. It maintained its structural cohesion, even though the forces acting on it should have been extreme. And then Loeb made a point that marked a turning shift in the analysis. If Atlas were behaving like a natural comet, the energetic stresses and material loss during perihelion should have torn it apart, but the opposite happened. The object retained its integrity, while simultaneously displaying mass loss behavior that should have required a much larger nucleus, or a nucleus with entirely different physical properties. Loeb didn't accuse anything, didn't hypothesize exotic explanations he didn't need to. The numbers themselves were already beginning to contradict the standard story. His message was silent, but unmistakable. Something is wrong with the assumptions, not with the data. Loeb's analysis then zooms in on the structure of the glow surrounding 3I Atlas, details that most viewers might overlook, but that carry enormous scientific weight. The new images reveal a striking elongation, extending at a position angle of 106 degrees, astonishingly close to the projected sunward direction of 115 degrees. This is not random. This is not noise. This is a persistent directional feature that mirrors what the Hubble Space Telescope had already captured back on July 21st, 2025, an anti-tail pointing toward the Sunday. That alone is unusual. But the new data adds something even more intriguing. The November images also show a weaker extension at 301 degrees, practically aligned with the anti-solar direction of 295 degrees. In other words, Atlas is displaying structural asymmetries in both the sunward and anti-sunward directions, an incredibly rare configuration for any natural comet, let alone an interstellar one. To put the scene into perspective, at the time these observations were made, Atlas was sitting 1.43 astronomical units from the Sun and 2.16 AU from Earth. The region captured in the Nordic telescope's field spans nearly 500,000 kilometers across 500,000 kilometers of illuminated dust and gas, yet with geometric patterns too coherent to ignore. And here's where the details become even more peculiar. The dramatic long-range jets, reported in earlier wide-field images, are not visible in this dataset. Loeb explains why these observations were taken using an R-band filter, which cuts out most gaseous emission lines, leaving only dust reflections behind. So, what we're seeing is not the full picture, only the dust component. And even with just the dust, the symmetry, the angles, the directional features, all of it hints at behavior that refuses to fit comfortably inside the category of natural comet activity. The stage is now set for the anomaly to deepen. This is where Loeb's tone shifts from analytical to truly alarming. After laying out the observational geometry, he turns to the physical implications, specifically the colossal jets reported in recent wide-field images. These jets, stretching 1 million kilometers toward the Sun and a staggering 3 million kilometers in the opposite direction, are not the kind of gentle outflows you see on ordinary comets. They are monumental structures, the kind that demand enormous amounts of material being ejected continuously. And here's the problem. A natural comet simply cannot endure that level of mass loss while staying intact. Loeb emphasizes a crucial point in comet physics. At Atlas's distance from the Sun, the outflowing gas should reach speeds of about 0.4 kilometers per second, roughly the sound speed of heated gas at that location. At that velocity, for the jets to reach lengths of 3 million kilometers, they must have been blasting non-stop for 1 to 3 months. Months of intense sublimation, months of relentless material loss. But if that were true, the nucleus of Atlas should have been under catastrophic stress, thermal stress, mechanical stress, structural stress. It should have cracked, fissured, shattered into pieces. That is what natural comets do. They break apart long before sustaining this level of activity. Yet Atlas didn't. It sailed through perihelion, arguably the most dangerous phase of its orbit, without shedding a single fragment. Loeb calls this profoundly surprising, but the phrase almost undersells the severity of the problem. For a natural comet to remain a single integrated body under these conditions would require physical properties that no known cometary nucleus possesses. Far greater strength, far greater thermal resilience, and far greater mass than the Hubble data indicates. The contradiction is unavoidable. The observed behavior and the measured size of Atlas cannot both be true under the laws governing natural comets. And from this point forward, the anomaly stops being subtle, it becomes impossible to ignore. If everything so far seemed troubling, what comes next is the part Loeb describes with unusual bluntness, because the numbers, when pushed to their logical conclusions, don't merely challenge the natural comet hypothesis. They destroy it. Loeb begins with a simple question. If the jets extend up to 3 million kilometers, how much material must have been ejected to sustain them? Using the reported dimensions, he calculates the mass density of the jet material at a distance of 1 million kilometers from Atlas. The answer is shocking. The density corresponds to a few million proton masses per cubic centimeter at that range. When multiplied by the outflow speed of 0.4 kilometers per second, Loeb arrives at a staggering mass flux, one so large it barely seems real. To sustain such jets, Atlas would need to eject 5 billion tons of material per month for each jet, covering an area of 1 million kilometers on a side. This is not a typo, not an exaggeration, not a speculative guess. It is a direct consequence of the observed jet lengths and the physics of gas outflow. And now comes the fatal blow. Sublimating that much carbon dioxide ice requires an energy budget of 6 pet-joules over the 1-month perihelion activity period. That's an amount of energy so large that for Atlas to absorb it from sunlight, it would need a minimum collecting area equivalent to a sphere 23 kilometers in diameter. But Hubble data already placed Atlas's size at a maximum of 5.6 kilometers, not 23. Nowhere close to 23. And if the jets were driven by water ice instead of carbon dioxide, the required absorbing diameter skyrockets to an impossible 51 kilometers. Loeb then highlights another equally crushing point. On real comet nuclei, volatile ice pockets usually cover only a small fraction of the surface, meaning even these gigantic estimates assume a level of uniformity that comets simply don't have. In short, Atlas would need to be orders of magnitude larger, more massive, and more energy absorbent than it actually is. And yet, it remained perfectly intact. A natural comet cannot eject that much mass, absorb that much energy, sustain that level of jet activity, and still remain a single unbroken body, not at 5.6 kilometers, not at 23, not at 51. The math is unforgiving. The physics is merciless. The traditional explanation collapses under its own contradictions. After laying out the calculations, Loeb draws a line in the sand. He doesn't say these numbers are curious. He doesn't call them unusual. He calls them a new anomaly, one that cannot simply be brushed aside by those who prefer the comfort of familiar explanations. Because here's the truth underlying every conclusion he presents. If Atlas truly remained a single, intact body after perihelion while simultaneously exhibiting jets that demand energy far beyond what its size allows, then something in our understanding of this object is fundamentally broken. Natural comets do not behave like this. Natural comets do not keep their integrity under this stress. Natural comets cannot sustain this mass loss with such a small nucleus. And yet, Atlas did all of it at once. Loeb's critique is pointed but fair. He argues that forcing Atlas into the category of a traditional comet requires ignoring every contradiction the data exposes. It is, in his words, an attempt to shove the anomalies under the carpet of traditional knowledge instead of confronting what the observations are clearly signaling. Then he quotes Albert Einstein, a quote that feels uncomfortably appropriate here. Knowledge is realizing that the street is one way. Wisdom is looking in both directions. Maybe, Loeb suggests, we've been looking down only one direction for too long. So what do we do now? Do we insist Atlas must be natural because that's the idea we're used to? Or do we let the data guide us, even if it leads somewhere unfamiliar? What do you think? Do these numbers convince you that something about 3I Atlas refuses to fit the old narrative? Let me know your theory below, because whatever Atlas is, this story is nowhere near finished.